some self-destruction here. Okay. So, first example, let P equal -3, -5. So I'm always a fan of sketching the point. I think I told you that when I teach this in Algebra 2, I make them always plot the point, draw the terminal ray, complete your triangle if you would like. Just gives you a pretty clear vision of what's going on, brings in SOHCAHTOA or Pythagorean theorem, which is what everything always boils down to. So, and this is on the terminal ray side of theta, so we got that. Find each of the trig functions of theta. In the triangle that I just created, do we know where theta is? Theta is kind of your reference angle here, okay? And if I'm doing the Pythagorean theorem, I need to complete this hypotenuse. Does anybody know off the top of their head what it is? Oh, I tricked you. I know. I want to make sure. That's not 4. This is not a 3, 4, 5 triangle. A 3, 4, 5 triangle needs the legs to be 3 and 4. Having the hypotenuse be a shorter length than one of the legs doesn't make much sense. Okay? So we actually have to do the Pythagorean theorem. 3 squared plus 5 squared equals the hypotenuse squared. 25 plus 9 is 34. Isn't it? 25 plus 9. Josh, you're making me nervous. So the hypotenuse is root 34. And now when they ask for the 6 trig functions, we can just do opposite. Oh, by the way, hypotenuse is always positive. Okay? So the sign is opposite -5 over root 34. So that's going to create a negative sign value. Opposite over hypotenuse. If you rationalize, that's -5 root 34 over 34. Cosine, adjacent over hypotenuse, -3 over root 34. Rationalizes. Tangent, opposite over adjacent, 5/3. So for the record, this whole all students take calculus thing, only tangent should have been positive. And of course that's what happened because that's the double negative that you get. Anything else is a negative over a positive, which is why sine and cosine are both negative. Quick question for you. We were given a point. Why is this y coordinate not just your sine value? Why does the sine not just equal -5? Didn't we say yesterday, in the previous days, that the y coordinate is the sine value, the x coordinate is the cosine value? Why is that not happening here? Because that shortcut only works in the unit circle. Very good. This no one suggested this was the unit circle. Obviously, once you calculate the hypotenuse, you realize it's not the unit circle. That rule only works in the unit circle. Now there is the -5 is kind of wrapped up in the sine value. The -3 is kind of is wrapped up in the cosine value. I guess you could say it's always the y value divided by the hypotenuse, right? Does that make sense? Because in the unit circle, that would be -5 divided by 1. That would be -3 divided by 1, and so it would end up being the coordinate itself. So, but, you know, if we draw the picture, we don't have to kind of remember that shortcut, and we just get our values here. Our other 3, cosecant, we're not going to, again, don't be smart about this. Don't reciprocate this one that's rationalized, because then you're going to have to re-rationalize. Just go back to this version of it and just reciprocate that one, and then you don't have to worry about rationalizing. Follow? For our secant, we'll just make that negative root 34 over 3. And for our tangent, cotangent, 3/5. Any questions on that? Okay, read the second one. Let's see what we have here. So this might be a new vocab word, quadrantal. What do you think it means based on what you're seeing down here? Right. It's not in a quadrant. It's on the border between two quadrants. Okay? So if you see that, that's what that means. So this, again, the best way, I think, other than obviously having it memorized, which you will soon have, the best way is to, I think of the unit circle and your coordinates. I'd say quadrantal. I don't really know. Last year? Quadrantal? Quadrantal? I don't think it matters. Honestly, I think the first time I saw that when I started teaching this course, I probably had to look it up because it's not really commonly used. So I don't know if you'll ever see it again, but in case you do. So now I think, like I said, the easiest way to do this is by the coordinate system, as long as you don't have them memorized, which I'll assume you haven't yet done that. But the sine of 0 is the y-coordinate, 0. The tangent of 0 is the y divided by the x, which is also 0. For our 90-degree angle, or our pi over 2 radians, same thing. The sine is our y-coordinate 1. The cosine of 90 degrees is y divided by x. 1 over 0 is undefined. Why did I say cosine? I meant tangent. For the 180, what's our sine value, Zach? Good. And our tangent value, Maria, 0. At 270, our sine value, Jack? Very good. And our tangent value at 270, Nate Z? Good. Okay, little subtleties. This is what the next one's kind of getting at. When you read problems, there are going to be little subtle pieces of information that are given to you that's going to shed light on what quadrant you're in. And the reason, obviously, that the quadrant is critical is so you know whether or not your function is positive or negative. So this is just kind of practicing that skill when it's really the straightforward question is just what quadrant are we in? Lots of times this information is going to be hidden, kind of, it's not meant to be hidden, but we kind of look past it. But we have to always be mindful of what quadrant we're in. So in this first exercise, if tangent is negative, that alone limits us to only 2 options. So what quadrants are we limited to? If tangent is negative, it eliminates 1 and 3, and it keeps 2 and 4, so 2 and 4. And where's cosine positive? 1 and 4. And so to be both of those things, we obviously have to be in quadrant 4. Next example, tangent is negative 2/3, okay? And cosine is positive. So then from that, they want us to find the cosine and the cosecant. First of all, think about, on your own for a minute, think about what quadrant we're going to be in. And then I'll have you hold up 1, 2, 3, or 4 on the count of 3. Go ahead, think about it for 30 seconds. Okay, hold up 1, 2, 3, or 4 on the count of 3. 1, 2, 3. Good, we're in quadrant 4. Tangent being negative means we have to be here or here, and cosine being positive puts us here. Now, what's going to be your approach to finding the cosine value then? So theta is somewhere in quadrant 4. Any ideas? It is, but sine doesn't have to be just -2, and cosine doesn't have to be 3, because there's other things that with that division could reduce to that, but you're... Well, yeah, that would be, but cosine might not be 3. Like sine could be -2/5, and tangent could be 3/5. And then, or it could be -2/7 and 3/7, and it would still reduce to -2/3 is my point. Jalen? Right. Make that triangle. So the tangent of theta should be opposite over adjacent. Now, which one of these is negative? This one, right? Because we're going down. So keep your negative sign with the 2, and your adjacent can just be the 3. So that would be a +3 and a -2. Now the Pythagorean theorem is going to give us our hypotenuse. So that's root 13 is our hypotenuse. Now we can find the cosine. The cosine is adjacent 3 over hypotenuse, which rationalizes the 13. And the cosecant is going to be the reciprocal of sine. So we can do this one of two ways. We can find the sine and then flip it. Or instead of doing opposite over hypotenuse, we can do hypotenuse over opposite. Yes? So the hypotenuse is root 13, opposite -2. So we would probably just put that negative. It's just more typical to see the negative either written completely out in front or with the numerator. Any questions on that? Reference angles. You definitely did this last year. So with reference angles, it's always in reference to the x-axis. So if we're talking with degrees, it's either in reference to 0 degrees / 360 degrees or 180 degrees. So it's always your difference away from those numbers or multiples of those numbers. So 345 is closest to 360, right? This is my favorite activity. Talk about using manipulatives. I mean, I could have been doing this for the past 5 days, but I just thought of it now. You like my terminal, right? It's a staple. I think I need, that's what I need. I'm going to request this next year. I need like a unit circle with a dial that goes around it. I could just throw it. Wouldn't that be nice? Because I like kind of get you to envision it, but I would, they always ask me what I need, and I think, I don't need anything but paper and pencils, but that would be a nice little thing to have. Hold on, I don't want to forget that for next year's class. Okay. All right, so then they won't be impressed with my paper clip or my staple abilities, but anyway. So if we open this up, see it opening? Even still, that's kind of annoying. You can't see because my hand's in the way. It's opening, it's opening, it's opening to 345. Yes? Which is how many degrees short of 360? All right, so there's your reference angle, 15 degrees. I know you guys know how to do this. This would be more useful for my Algebra 2s who've never seen this before. Now, with radians, I obviously don't think 0 and 360 and 180. And also in radians, I don't think the same thing on every type of radian problem. if I'm thinking about problem B with a 6 denominator, I think of this as 6 pi over 6, and this one as 12 pi over 6. If I'm dealing with thirds, and I'll just jump down to that one because I'm talking about it, I think of it as 3 pi over 3 and 6 pi over 3, because then it's just easier to place. It's all relative, right? So if I'm opening up my unit circle to 5 pi over 6, that's going to be one tick shy of 6 pi over 6. So what's the difference between 5 pi over 6 and 6 pi over 6? Pi over 6, and it's much easier. Jump down to F. If I go around one full circle, I'm at 6 pi over 3. So what will this one be? 3 pi over 3 slash 9 pi over 3, right? Because you add on 2 pi, which is 6 pi over 3. So if I want to go to 8 pi over 3, again, that's one tick shy of 9 pi over 3. So 8 pi over 3, the difference between that and 9 pi over 3 is pi over 3. And let's just do G while we're at it. So 6 pi over 6, so, and it's negative, so I would think 0. This is negative 6 pi over 6. Keep going around. This is negative 12 pi over 6. So negative 13 pi over 6 is one tick past. What's the difference between negative 13 pi over 6 and negative 12 pi over 6? Pi over 6. Here's the thing with reference angles. They have to be positive. So I see why a couple people said negative pi over 6, but reference angles have to be positive, and they have to be between 0 and what? Well, they don't have to be positive. They have to be non-negative. How's that? Because they can be 0. And 90, correct. That's talking degrees. If we talk radians, less than or equal to pi over 2. Okay? Now, I do the 3 radians first, and I sort of talked about this the other day. Once your radian measure is in simplest form, for the record, this is only true for our reference ones that we have memorized. So it's only true for our pi's over 2s, our pi's over 3s, our pi's over 4s, and our pi's over 6s. But once it's reduced, whatever that denominator is, that's your reference angle. Whatever your denominator is, that's your reference angle. Whatever your denominator is, that's your reference angle. It's pi over the denominator. Does that make sense? So when someone gives you something ridiculous like 101 pi over 4, it's just pi over 4. If someone gives you 1,003 pi over 2, it's just pi over 2. Okay? As long as the fraction can't be reduced. Like if someone gives you, 80 pi over trying to think of one that will reduce into another. Let's just pretend I get 80 pi over 6. That's going to reduce to 40 pi over 3. Yes? So the reference angle is pi over 3, not pi over 6. Is that clear? It's just a shortcut that is going to save you the logical process of kind of spinning round and round and round and envisioning what this is going to be. Okay? And again, that's only true for our main angles, pi over 3, pi over 4, pi over 6, and pi over 2. Okay? For the record, just so we know the equivalents, pi over 2 is 90, pi over 3 is 60, pi over 4 is, and pi's over 6's are 30. And that's because pi is just 180. Pi is the same as 180 degrees. So 180 divided by 2, 180 divided by 4, 180 divided by 3, 180 divided by 6. Good? Okay? If we jump to the degrees again, we're going to negative 135, which is going to be just short of 180 by how much? 45? 2.5. This is not degrees, otherwise there would be a degree symbol. But it's also not radians in terms of pi, it's just straightforward radians. How many radians is this in decimal format? Nope. 1 radian is over here somewhere. This is pi radians. Pi is 3.14-ish. Yes? Half of 3 is 1.5, so this is like something like that. But where does 2.5 then fall? Which quadrant? Right, if I'm opening up my reference angle, it's going to land somewhere in there. That's going to be 2.5. So what's the difference between 2.5 and approximately 3.14? 0.64. So, you know, I wouldn't ever put it overly close to that because that's not a value that we memorize very well. So it will be kind of, you know, obviously in quadrant 3 or obviously in quadrant 4. I'm not going to give you something close to the border because these decimals aren't ones that you know very well, but if it's slightly past 3.14 versus slightly prior to 6.28, it's not going to, like I said, I'm not going to put it down here so you're debating, oh geez, which one is that in, because you don't have a calculator. Use 3. That's true. That's true. But because this is to the nearest, you know, tenth, and we're okay with a decimal radian, I'm just going to use the 3.14. But that will come up on your homework, so you know what to do with that. And then 580. Okay. Instead of dealing with 580, find a coterminal to that. So if we subtract 360 off of that, we get 220. And which quadrant is 220 in, Kendall? The third. There's 220. Here's 180, reference angle. Anybody? 40. Now that reference angle is not all that helpful because 40 is not one of our memorized values, but it's still a reference angle. Okay? Any questions so far? Okay, so exact values. So using your reference angles, using your memorized values, using your all students take calculus cheat method to kind of come up with the exact value here. So first of all, what quadrant are we in? 135. 2. So is the sign positive or negative? Positive. So it's the same. And what is the reference angle? 45. So the sign of 135 is going to be equivalent to the positive version of the sign of 45. The positive comes from the quadrant that we're in, and the fact that sign is positive there, and 45 comes from the reference angle, and the sign of 45 is just root 2 over 2. Good? Stephen? What rule? Because they both have the same reference angle. So whether you're creating your triangle here or creating your triangle here, they're both 45, 45, 90 triangles. So your reference angle to the x-axis, this is why we always drop our altitude to the x-axis to complete our triangle. Your opposite over hypotenuse here is going to be the same as your opposite over hypotenuse here, give or take a minus sign in certain cases, depending on which quadrant you're in. But here, your opposite side is still in the positives. So that's why your sign your sign is remaining positive in this quadrant, because your opposite side is remaining a positive coordinate. Okay? So here we are with this one. What quadrant are we in? Think 3 pi over 3 is here. So 4 pi over 3 is one tick past, right? So we are in quadrant 3. What's cosine there? Negative. So this is going to be the same as the negative cosine. And what's our reference angle without much thought? Pi over 3. No, don't go from radians to degrees. Think radians if it's in radians. And then the cosine of pi over 3 is 1/2. Yes? What quadrant are we in here? Four? I'm surprised at the delay. Just 1 pi over 3 in the negative direction. We're definitely in 4. So, now cotangent is like tangent. So is that positive or negative in the fourth quadrant? Negative. So this is going to be the same as the negative cotangent of, what's our reference angle? Pi over 3. Now, what's the tangent of pi over 3? Radical 3. And so the cotangent is going to be the reciprocal of that. And then rationalize is negative radical 3 over 3. Stephen. I mean, if you look at pi over 3, you can and you may just see 60, and that's okay. What I'm more talking about is like here. Don't take that and go to degrees. Right. So now that you caught onto the shortcut of 4 pi over 3, reference of pi over 3. If for like a snapshot you think, okay, cosine 60, that's okay, right? So I want that to be automatic though. When you see pi over 3, you see 60. If that's kind of uncontrollable, but I'm not taking something like this and going into degrees and then doing all that nonsense to go from the degrees to the reference angle. Do you see how much longer that takes? So if you see 4 pi over 3, I am not doing 4 times 180 over 3. I'm not changing the 4 times 60. That's 240. Where would 240 go? Which quadrant? That's way too hard, right? By thinking in radians, I'm saying 4 pi over 3 is a reference angle of pi over 3. Okay, got it. If you think 60 there, fine. That's fine. But then also, like placing the quadrant, I want you to think in radians. Like 3 pi over 3 is here, so 4 pi over 3 is here. Because the translation of that to 4 times 180 over 3, which is 4 times 60, which is 240. 180's here, 240's in here, is a lot longer. Maybe only a couple seconds, maybe only 5 seconds for some of you, but it's longer. And like, we can't stop and have all of those. That's a long thought process. It might happen quickly, but it's a long domino effect. And I want you to get it faster. But I don't have a problem, and honestly, I might even admit that I do the same thing. When I see pi over 3, my mind just says 60, and I just give you the answer. That's okay. All right. 14 pi over 3, what's the reference angle? Pi over 3. So now, what quadrant are we in? We've got 3 pi over 3, 6 pi over 3, 9 pi over 3, 12 pi over 3. 15 pi over 3. What quadrant are we in if this is 15 pi over 3? 2. So is tangent positive or negative there? Negative. And the tangent of pi over 3 is radical 3. So we've got the negative radical 3. And last one, what's our reference angle? And what quadrant are we in to find out if this is plus or minus? We've got negative 4 pi over 4, negative 8 pi over 4, negative 12 pi over 4, negative 16 pi over 4. So what quadrant is this going to be in? Negative 17 pi over 4. Are we all on board with that? Now secant is the same as what? Follows the same rules as what? Oops. Cosine is correct. So is this positive or negative in the fourth quadrant? Positive. So the cosine of pi over 4 is root 2 over 2. So the secant is going to be 2 over root 2, right? Which rationalizes to 2 root 2 over 2, which is just root 2. All right. You did all this last year, right? This may be a little different way of thinking about it. Hopefully it just helps round out what you already know.